Hello, this is Mabel Britt presenting my AI research project for CS 199. My professor was Victor Cecci in this class at DigiPen Institute of Technology. For my project, I created Minesweeper Upgraded. I love Minesweeper. When I'm bored or I need a break, I'll go to this site and play it. And what I often hear when I'm playing it, in front of friends is, wait, you're not supposed to just randomly click on squares until you lose? A lot of people don't know the mechanics of Minesweeper, which I think is a shame because it's a really fun game. So what is Minesweeper? The goal of Minesweeper is to clear a board that has hidden bombs spread randomly across the board. The board is made of tiles that the player can click to clear. When clicked, the tile will either be empty, have a number that counts the bombs surrounding that tile, or it could be a bomb, which would then cause the game over and clear the board, revealing all the bombs. Here's an example. Here is how to play Minesweeper. The player can strategically flag and clear tiles by narrowing down where bombs are based on the tiles that reveal how many bombs are surrounding them. For example, we can see here that there's a 3, and that means that it has 3 bombs surrounding it in this little 9x9 area here. But it only has 3 tiles next to it that are uncovered, which means all of these tiles are bombs. We can flag them using right-click with our mouths, and this will stop these from ever getting accidentally clicked. Once those are flagged, you can then see that this square that has 2 surrounding bombs, we've already flagged the 2 surrounding bombs that it has. So we can now clear these 3. Now that we've cleared those surrounding the 2, we can see that the 1 also has 1 bomb surrounding it, and we only have 1 tile surrounding it. So we can now use this process of elimination to flag this one, and so on until you get a win state. The problem with Minesweeper is sometimes it is impossible to solve. For example, right here we have 4 surrounding bombs, and we have 3 here, so it's either under one of these 2. Same with this 2, we have 1 here, so it's either under one of these 2. Same sort of percentage possibility of each scenario. Same with this, and same with this. We only get 1 piece of information for both of these, which I always find really frustrating, especially when you clear like a 16x30 board and you get to 2 last tiles and 1 bomb left, and you have to just pick a 50-50 chance, and then you might lose, which is really frustrating after clearing the entire board. And I just personally don't like it. So how do we fix it? Using an AI, I want to detect impossible scenarios and either automatically reveal the bomb / empty the space to the player when they encounter it, or immediately change the scenario to make it solvable before the player even clicks on the board. The only way to detect impossible situations, though, is to make an AI that can play Minesweeper, which means I have to make my own version of Minesweeper. So let's begin. To make Minesweeper, I automatically create a board filled with these units that have flags and bombs and numbers that will count the bombs that surround it. And I created a 2D array that I can use in code to track the current game state of the board. Almost all official Minesweepers make sure that on the first click of any game, the player can never use. This is because losing on the first click would be super frustrating and kind of meaningless. Official Minesweepers did this by taking the bomb, if the player ever clicks on it for their first click, taking that bomb underneath their first click and putting that in the first tile. If that first tile already had a bomb in it, then it would put it in the next one, so on and so on, until it reached a empty covered tile that it could hide the bomb in. I did not do this. I learned that the Microsoft official does this after I did my own way, so this is how I did it. Instead, I basically fill the board with randomly generated bombs after the player clicks on their first tile. So here's an example of that. I also changed it so any surrounding tiles, so not just that tile, but the 9x9 area around that tile, would also not have any bombs. Just because it can be kind of frustrating when you first click on one and it's like an 8 and you don't have any information left. So how did I do this? Here is some code. I have 2 for loops, which loop through the entire grid. And if it is any of those squares that the player first clicked on, then that is immediately false. Always, always will never have a bomb. It will then randomly place a bomb, which is dependent on the number of bombs that are required to be on the board and the squares left. More intricacies. There are some quality life additions to Minesweeper that I also feel are very necessary to the game. The first being automatic connected empty square cleaning. Basically, when a player clicks on an empty tile with no surrounding bombs, it automatically clicks on all surrounding tiles because there would be no bombs on it if it's blank. This is completed by me using recursive code that calls the function whenever a blank tile is clicked and has no surrounding bombs, which then clicks on all surrounding tiles. The function is not called on any surrounding tiles that do have a number. So here's the code itself. So the function is called whenever the player clicks on an empty tile, which it also checks that this unit has no surrounding bombs. And it makes sure that it's not any of like the, let's say this is like a corner tile, so it's like 1x1. It makes sure that it's not trying to click on like -1, -1, which would be bad. And as long as it's not outside of the grid, it clicks on the tile. And it keeps on doing this until all the empty squares are cleared. Another thing that I really appreciate in all of my Minesweeper games are quick player clearing, which is basically allowing the player to clear any square in a 9x9 radius of a state that already has its bombs flagged. So as you can see here, I have a 1 there and I just right-clicked on it and just immediately cleared. And this doesn't allow for cheating, as you can see at the end there. I flagged the wrong one purposefully, and when right-clicking on the square, it cleared the non-flagged squares, which, because it was the wrong one, it clicked on a bomb, which set the game over state. To automatically clear the squares, I do something very similar to the automatic square clear, where if the number of flags surrounding this tile is equal to the number of bombs surrounding this tile, so when the player has 2 bombs and 2 flag tiles, and the player clicks on the 2 to clear the surrounding tiles, it then goes through and does not click on the flagged ones, or any of them that might be out of the grid height or grid width, and then clicks on those. Alright, now we gotta do AI. Let's start off with solving simple 3x3 game states like what I showed in the how-to. The 3 has 3 units surrounding it, so the AI should be able to detect that there are 3 bombs and 3 surrounding units, so all of these empty squares should be flagged. Then the AI should detect situations like this too, where it already has 2 tiles surrounding it that are flagged, so all of the other tiles should be cleared. We start with the for each loop. This goes through the entire grid. I then check that all the units that it looks at have the covered unit destroyed. This way, I know that the AI is only looking at tiles where information has been revealed. Then I check that the tile does not have 0 surrounding bomb counts, because if it does, all of the tiles around it have already been cleared and it would be unnecessary to look at this. Then, if all of the surrounding bombs are equal to the number of surrounding flags, so either the player or AI has correctly flagged all of the bombs around this unit, then it automatically clears all of the surrounding tiles other than the flag tiles. Next, we had to look at any situation where there were some tiles flagged, but some tiles not flagged, and the tiles left that were not flagged were equal to the bombs that were still needed to be flagged. If it meets any of these criterias, then it toggles a flag on the tile. You might also ask, what are these things? I have this little flag here that starts as true, and if it encounters either of these scenarios, it's changed to false. Keep that in mind, but I'll get to it later. So I now have an AI that loops through the board and solves any obvious states. So there we go. But there is still stuff that we can't solve. For example, this one is solvable because we still have more information that we could reveal in this tile, which definitely is not a bomb. This situation is very solvable, but you have to take in this entire 5x3 space. This situation is unsolvable. There are 3 equally likely solutions to this, and no matter what, the AI and most people will run into this and not be able to solve it. So how do we fix that? Now we have to do some cheating with the AI. The unsolved boolean that I pointed out earlier helps me track if the board is currently impossible to solve. Once the AI cannot solve a board, it should just cycle through each tile and randomly flag or clear a tile, depending on whether or not it is a bomb. I did it like this. If unsolved is still true, so it goes through the entire board and it can't solve anything, then we make a list of all the unflagged and covered units, so basically all of the units that are currently unknown, and we randomly select one of them, and if it's a bomb, then we toggle its flag. If it's not a bomb, then we click on it. So now I have a function that can solve a game state, and if it can't solve that game state, it can change the game state by cheating a little bit. So to make an AI that solves Minesweeper, I can just create a function that loops quick solve until the board is complete. I also made it an enumerator, so then it delays a little bit after every quick solve loop, which lets you see the process and makes it a lot more satisfying. And I also did 20 by 20. And 40 by 40. Of course, my computer did slow down once I get to these 1020, but it still works. So, I have solved Minesweeper. Not really, but now what? I really want to work on this over the summer just because I had a lot of fun on this and I really love Minesweeper and I'd really like to make my own that I can actually play. So first thing I want to do is fix the board problem. One thing I didn't mention that bothers me a lot is that the board will only spawn square boards, so 20 by 20, 40 by 40. It doesn't work for rectangles, which is strange because when looking over my code it should, but I need to figure out why it does not. Next thing I would want to do would be create a menu where the player would be allowed to select from easy, medium, or hard. So smaller boards with less mines to bigger boards with more mines. And letting the player choose whether or not to have a quick solve button. And also even letting them create a custom board. I would also like to add more feedback, just because particle effects and audio is nice, and I enjoy having it. I would also like a rating system, which I could probably do right now in terms of AI. I could create a system where the AI plays a board before the player even starts and counts how many times it runs into a difficult scenario. And then it will only show the player boards that ran into a difficult scenario less than 10 times or less than 5 times. Sort of a stretch goal for me, which would probably take a lot of effort, but I'm still sort of interested in doing, would be calculating solution probabilities. Basically, to do that, I would have to make theoretical boards with theoretical possible solutions, and make all of the different valid theoretical possible solutions for any unsolvable game state, and then calculate the probability of each. And this would also solve any of the unsolvable situation that my AI is running into right now. That takes a long time, though, and is very much out of my skill set. My end goal with this project is to create a Minesweeper website that I can just go to when I'm bored or I need a break, that I can customize on my own to make sort of the Minesweeper that I enjoy the most, just because it's a game that I go to so often when I just need a little bit of a break. And I would love to sort of make it what I enjoy about it. Thank you for watching my presentation. Here are some websites that helped. Very interesting sites. I highly recommend all of them. Thank you so much for watching, and have a great day.